All right. In today's lecture, we're going to talk about environmental conservation, specifically focusing on different biomes that we should be conserving, including forests and grasslands, and then the different designations of parks and nature preserves. So the first thing we need to delve into is this case study on palm oil and how the monoculture of palm trees for the harvesting of palm oil is really contributing to some of the greatest endangering of species on our planet, including the Sumatran tiger and the orangutan. So I'm going to play this movie for you, very, very short video.
There's a good chance you're not familiar with it, even though you'll find it in many of the products you use every day. It's in everything, from makeup and toothpaste to donuts, chocolate bars, and in some countries, biodiesel fuel. It goes by many names, but it's most commonly known as palm oil. Global consumption of palm oil has quintupled since 1990. Oil derived from the palm fruit is easy to extract, has a higher yield than other types of vegetable oils, and can be used in dozens of products. But the proliferation of palm oil also poses a massive environmental threat. Each year, palm oil plantations destroy millions of acres of forested land, create billions of tons of carbon pollution, and kill endangered wildlife. All of this makes the palm oil industry one of the worst environmental offenders on the planet. In 2015, over 62,000 square miles around the world, much of it former forests, were committed to palm oil plantations. That's an area 4 times the size of Switzerland. Palm oil is one of the top 3 drivers of deforestation in Indonesia, a country that supplies more than half of global demand. Each year in Indonesia, fires are set to clear forested lands to make way for palm oil production. Just last year, over 10,000 square miles were torched, creating fires so big they could be seen from outer space. All of this unleashes massive amounts of carbon into the air. Fires in 2015 added more than 2 billion tons of carbon dioxide and other greenhouse gases into the atmosphere. The burning of forests to clear land for plantations threatens the 10,000 square mile Luso ecosystem in Sumatra, the largest intact swath of rainforest in Southeast Asia. It's home to hundreds of unique species and is the only place left in the world where orangutans, rhinos, tigers, bears, and elephants live side by side. But their home is disappearing around them. The Sumatran tiger and the Sumatran rhino are threatened with extinction. Only a few hundred of each species exist in the wild, and their habitats are often in the path of land clearing. In Borneo, there has been a 50% decrease in orangutan populations in the past 65 years. This is a direct result of the forest fires and conversion of woodlands for palm oil cultivation. Alongside logging and mining, land clearing for agriculture is currently one of the leading causes of deforestation. If consumers don't demand more sustainable practices soon, the products we buy can and will contribute to the loss of the world's rainforests. You can help by purchasing products that do not contain palm oil, or if they do, were made sustainably. Go to takepart.com/palm oil for more information.
All right. So that's just a preamble to the focus of our lecture and concentrating on why it's important to put forth conservation efforts and the different types of ecosystems that should be of focus. Specifically, that was looking at woodlands, which are a type of forest. Also included in the world's forests are pastures, rangelands. Together with forests and woodlands, these occupy about 60% of global land cover, so pretty substantial. And they provide a lot of essential resources for us to use and to mine for our purposes as humans, including lumber, paper pulp, and grazing lands. But as always, not only do these natural resources provide supplies and products for us, but of course they have ecological services as well, including regulating climate, controlling water runoff, providing habitat for wildlife, shelter, purifying air and water for both humans and other animals that are in these habitats, and then finally supporting rainfall so these areas do not experience massive flood events. We can take a look at the breakdown of world land use and forest types. Here on the left is just the biggest pie chart with the broadest categories. The other here makes up 33%, and that includes biomes like the tundra, deserts, wetlands, and urban areas. But we see that the largest chunk of the pie here is taken up by range and pasture at 27%, and then also forest and woodlands at 29%. We can focus in on the forest and woodlands here, blowing up that red piece of the pie into its constituent parts. And we see by and large, the forest and woodland type habitats are mainly boreal forests and tropical moist forests, together combined taking up over half of the forest and woodland type. So boreal and tropical forests are most abundant in terms of the different types of land. And in order to be a forest, that means that you have trees that cover more than 10% of the land. Old growth forests are a specific type of forest, and these are forests that have been undisturbed and live about their natural life cycle. What's to note, though, is that about only 25% of forests retain their old growth features. Many of these forests have been disturbed either through natural disasters or human processes. The largest remaining areas of old growth forests are actually located in Russia, Canada, Brazil, Indonesia, and Papua New Guinea. So notice North America is definitely not on this list. Forests are really important, again, for the ecological services that they provide. One of those key ecological services is being able to sequester carbon or store carbon. In these forests, we know that they, on average, can store about 422 billion metric tons of carbon in standing biomass at any given time that you measure them. Okay, so that's just a whole lot of carbon that is currently being stored and sequestered away from being oxidized and sent into the atmosphere. So again, the sequestration of carbon is a very extraordinarily important ecological service that forests provide to us. Here we have the net change in forested areas by country. We have on the y-axis here, forested area reported in 1,000 hectares. And then over here on this other y-axis, we have percent change. The blue bars represent forest area, and the red bars represent percent change. And we're talking about a period of time from the year 2005 to 2010. The largest annual net deforestation rate in the world, we can tell from this graph, is actually in Africa. We can tell that by looking at the depth of this red bar. So net deforestation is going to be symbolized by a red bar that is below this 0% change line here. And we see that the biggest bar that extends to the greatest extent downward is in Africa. Okay. We also have net deforestation happening in South America as well as Oceania, but by and large, Africa has the largest percent change in net deforestation. We can take a look at China, which is an interesting case in Asia here. And we notice that we don't have net deforestation, we have net reforestation in this area. And that's largely because China has planted 50 billion trees in the past decade. So because of that, Asia, the entire continent, has a net increase in the amount of forested area. We can take a look at Europe too and see that also Europe is gaining forest as well, not by nearly as much as Asia, for example, but it is still a net positive reforestation here. And then we can take a look at North and Central America and see that there is no net change at all because there's no red bar. So here, just to sum this up for you, China has planted 50 billion trees in the last 20 years, causing this red bar to be above that 0% change mark. Japan and Korea have restored about 70% of their forests since World War II, again, contributing to that net increase in forested area in Asia. And then Africa and South America still see the highest rates of deforestation in their region. So why is deforestation such a thing? Of course, humans, we like to scavenge resources from the environment. What kind of resources do we use? Well, about 20% of all wood consumption is used to produce paper. So we are in fact using tree resources to produce paper for our consumption. But in addition to paper, we're also using that wood for fuel. And fuel wood accounts for about 50% of global wood consumption. And about 2 billion people depend on wood for heating and cooking. So there's a lot of value placed on wood in these forests, not only for paper production, but also to heat and to cook, basically just to live. Talking about monoculture forestry. A monoculture is when you're growing a single species in an area. So back to that case study of the palm oil example, these agricultural lands are being cleared for the monoculture of palm trees, which is exactly what we see here. It's just row after row after row after row and hectare after hectare of a single species, and that's of palm. 25% of the world's forests are managed for production. This has both benefits and costs. So a couple of benefits for monoculture forestry is, number one, you can expect to see high growth rates of that monocultured plant. It's also sustainable and easy to harvest in that area typically. But of course, there are problems that coincide with monoculture forestry, as you can imagine. Number one, low biodiversity. If you're only looking at one plant species, it's extremely not biodiverse. You're only looking at one species, and therefore, not only is there one species that you are planting, the biodiversity overall in that ecosystem is going to decline because you don't have a rich community of different species that rely on different plants for food, for example, for shelter, for example, and life habits. In addition, there's little wildlife value in these monoculture forests, again, because of the low biodiversity that is caused because you're planting just one species. And finally, soil damage. Oftentimes, planting the same thing over and over, it fails to replenish nutrients in the soil. And after a while, monoculture forestry ends up producing barren soil that can no longer support even that one species that was the target of your agriculture. So tropical rainforests, as we know, unfortunately, are being cleared very, very rapidly. About 100 years ago, there were 12.5 million square kilometers of these tropical rainforests. That's an area that's greater than the entire contiguous United States. So taking a look now, fast forward 100 years later, only 40% of that 22.5 million square kilometer range of tropical rainforests exists today. Tropical forests are among the richest and most diverse terrestrial systems on our planet, as we discussed several lectures ago, and this has to do with moisture content and nutrient availability in the ecosystem. About 10% of the Earth's land surface contain more than 2/3 of all higher plant biomass and at least a half of all plants and animal species. So read that again. The tropical forests on our planet cover only about 10% of the Earth's land surface, but despite only being 10% of the land surface, they contain half of all of the plant and animal species on our planet and 2/3 of all higher plant biomass on Earth. Satellite imagery can directly capture the change in deforestation in these tropical forests. For example, this is Landsat imagery or land satellite imagery from Santa Cruz, Bolivia, going from summer of 1990 all the way through 2020, with green areas indicating forested regions and then pink and red areas indicating that there's no longer forest there. So we can clearly see a progression through time with increasing deforestation, with maybe some efforts to reforest some areas, some target areas. So about 10 million hectares, or 0.6% of these tropical forests, are cleared each and every year. And just to put that into some sort of perspective or reference for us to wrap our mind around, 10 million acres is about 12 million football fields that we are clearing. So why are humans doing all of this clearing? Why are we causing all of this deforestation? There are a couple of causes and a variety of factors that contribute to deforestation. The primary cause is the building and construction of roads. You can imagine how important and paramount roads are in any society, connecting different communities, connecting villages to hospitals. So they are crucial parts of human infrastructure in order to have a thriving human population, but this wreaks havoc and is extremely devastating in these tropical forests. So the primary cause of deforestation is roads. These roads allow entry to the forest by farmers, miners, hunters, and others who would cause further damage. So it's not just, building those roads for basic infrastructure, but it's also access points for those who are seeking to continually exploit the natural resource of the tropical forest. In addition, you also have commercial logging that is pretty lucrative and financially beneficial to the communities that inhabit these ecosystems, either having these woods that are pretty expensive like teak and mahogany, or again, logging for wood fuel, for example. And finally, the conversion of forests into small scale agriculture. This doesn't necessarily entirely clear out a forest, but what it does do is causes fragmentation of a large forest and breaks up that large forest area into smaller parcels of land that are not going to support nearly as much biodiversity as a undisturbed large area would. Again, getting back to the edge communities versus the core communities. So what I would like you to do is read in your textbook, pages 136 to 137, and answer these two questions. Number one, how does deforestation contribute to carbon emissions? And number two, what are some tropical forests or things that were formerly forests that contain resources that you use? So what are some resources that you use that you can identify come from forests or parts of the earth that were formerly forests? What I want you to do is put your answers to these two questions in the week 5 folder under the deforestation assignment. And on your first exam, these two questions are going to count for up to 10 points on your first exam. So these aren't 10 extra points. These are points in your exam that you get to work on outside of the exam itself. So in addition to those tropical forests, we also have temperate forests that are at risk. The United States and Canada have also allowed controversial forest management practices. This is primarily occurring in the Pacific Northwest in regards to timber logging practices. And that's because the U.S. Forest Service encourages multiple use forests. So this is where forests are used for multiple purposes at the same time. But many times the multiple uses are basically incompatible with each other. They don't comport. There are several different types of harvesting methods. The first that you're probably most familiar with is just clear cutting. This is where every single tree in a given area is cut or burned down, regardless of size or level of maturity. But there are other alternatives to clear cutting. The first of which includes shelter wood harvesting. And this is where mature trees are removed in a series of 2 or more cuts. You also have what is called strip cutting, which is depicted here on the right. And this is where all the trees in a narrow corridor are harvested for timber or fuel, for example. Okay, so this is an example of strip cutting. And then finally, you have selective cutting. This is where only a small percentage of the most mature trees are taken in each 10 to 20 year rotation. So there's timing involved in selective cutting, and there's also the age of the tree that is being considered in selective cutting. So in addition to harvesting methods, there's another side of this coin in fire management. Okay, following a series of disastrous fire years in the 1930s, the US Forest Service adopted a policy of aggressive fire control. And you're probably familiar with Smokey the Bear, which is depicted here on the right. Only you can prevent forest fires. Smokey Bear was adopted as the forest mascot in the 1930s in response to these disastrous fires that overtook areas in the United States. But the problem with this type of fire management is that many biological communities are actually fire adapted and they require periodic burning for regeneration. And we've talked about those disaster adapted species. A lot of forest dwelling organisms, including trees and warblers and short grass prairies, they are fire adapted and they require fire as part of their ecology. So eliminating fire from these forests has allowed woody debris to accumulate on the forest floor, greatly increasing the chances of a very big fire. So rolling into fire management is just overall ecosystem management of these temperate forests. In the 1990s, the US Forest Service shifted from harvest to ecosystem management. So what this did is it attempts to integrate sustainable ecological, economic, and social goals with the overall goal of having an ecosystem that is managed in ways that is consistent with the ecology, the natural ecology of that ecosystem. So in this, you're allowed sustainable exploitation of the ecosystem as long as it is manageable and the expectations are understood. In these ecosystem management practices, the use of the ecosystem as the model for how we produce and extract our needed goods is used. So whenever we are doing exploitation of these ecosystems, according to the US Forest Service, we must use the ecosystem as the model for how we carry out the extraction of goods and products. It's always with the health of the ecosystem in mind. Agriculture is a very poor example for how we manage our ecosystems, again, with the use of monoculture forests. It is not the natural state of the ecosystems, and certainly that is a very poor example of how we manage our ecosystems. There are a couple of criteria for sustainable forestry, and these include conservation of biological diversity, the maintenance of productive capacity of forest ecosystems, maintenance of forest ecosystem health and vitality, maintenance of the soil and water resources in that ecosystem, maintenance of forest contribution to global carbon cycles, and finally, maintenance and enhancement of long-term socioeconomic benefits to meet the needs of legal, institutional, and economic framework for forest conservation and sustainable management. So that is a mouthful, but all of this has to do with the practice of sustainable forestry. Okay, coming back to our pie charts that we started our lecture with, instead of zooming in on the forest ecosystems here, we're going to focus in on range and pasture lands, which take up this other big chunk of the world land use types. Specifically, we're focusing on grasslands. Grasslands and the grassland biome represents the second most used biome by humans. How does this translate into numbers? The 3.8 billion hectares of pastures and grazing lands in the grassland biome make up about twice the area of all agricultural crops. So grasslands are extremely utilized for human consumptions of goods and raising cattle in pasture lands. Worldwide, the rate of grassland disturbance each year is 3 times that of tropical forests. So just to put it into scale in relation to what we learned about tropical forests, grasslands are disturbed even at a higher rate than those tropical forests. This disturbance mainly comes about through livestock grazing, and a massive amount of habitat in our world is utilized for livestock grazing, not only in the United States, but across the globe worldwide. Collectively, we call this grazeland we call it rangeland, and it covers about 25% of the Earth's surface. This type of habitat has largely been ignored by conservationists because it was assumed that a grazer is a grazer, they're all the same. But we do know that bison are very, very different from cattle. And this is just one case study of how a grazer actually isn't just a grazer. Okay, so When we take a look at the evolutionary history and the co-evolution between grazers and what they graze upon, we need to focus in on the bison and understand that the grasses of the North American continent actually evolved with the bison. So bison and grasses have this long history throughout evolutionary time of being in this co-evolutionary relationship with each other. In addition to that, bison do not linger around water, and they are actually highly selective in the plants that they eat. They don't linger around water, and they also move around constantly. Okay, so that is a life strategy and life history of bison. But let's take a look at cattle. North American range did not evolve with cattle. So the grasses in the North American continent don't have this long evolutionary history or co-evolutionary relationship with cattle that we use in our rangeland. Cattle, they linger around waterways, and in this lingering, they tend to destroy riparian habitats, as depicted here. So they chomp on all of this greenery, and they also just stamp around and move back and forth, and this causes erosion. In addition to that, they also eat everything, and they are extremely unselective in the type of food that they eat. And finally, they tend to stay in one place and eat the area down unless they are moved physically from that area. Okay, so this is all to make the point that a grazer is not a grazer. Bison and cattle are very different types of grazers. So what do we do in this context? Well, number one, just try to use native grazers to whatever land that you're in. And we must always remember, why did we bring cattle to the American West in the first place? Beef actually wasn't really popular of a meat in the early American West days. The cattle that were brought over were mainly used for their skins and their tallow, their animal fat. And finally, later, meat became marketable and lucrative. You can also harvest native organisms for the use of grazing. An example of this is the eland in Africa. It's actually the world's largest antelope. So it definitely doesn't even look like a cow or a bison. So we can harvest native organisms, and we can match grazing patterns between the type of grazing material that's there and the type of grazer that we are recruiting. So we can have grazing rotations, for example. We can control livestock numbers, or if not, overgrazing can lead to this process called desertification. So breaking it down, desertification, basically making a grassland like this graze down so far that it turns into a desert biome. So desertification here. So all of this overgrazing, of course, leads to degradation of the soils, and this threatens many rangelands worldwide. We can take a look at the numbers here. So with world at the top and then broken down by continent here or country, we have in red soil degradation due to overgrazing. This is on the right, and on the left in blue, soil degradation due to other causes like farming, logging, mining, urbanization. And all of this on the x-axis is reported in million hectares. So notice that in Europe, over here, in Asia, and the Americas, that these other causes in blue, like mining and urbanization, are responsible for about 3/4 of the soil degradation. But when we look at other areas like Africa, for example, where grazing occurs in a desert environment or a semi-arid scrub biome, the grazing damage is a lot higher over here. So how do we take steps to protect these lands? Well, we turn to the creation of parks and preserves. Forests and grasslands serve utilitarian purposes. We also set aside natural areas for aesthetic purposes. So forests and grasslands serving for utilitarian purposes, that means that we use them for a purpose that has a cause that directly, most of the time, can be tied to monetary advancements or making money. But in addition, we also set aside natural areas for aesthetic purposes, just being out in nature and enjoying nature for nature's sake. 13% of the land area on Earth is protected in some sort of park, preserve, or wildlife management area. And this 13% represents about 19 million square kilometers. And that is divvied up in over 100,000 different preserves on Earth. The problem with this is that these preserves are highly fragmented across the planet and even within countries. So a little bit of definitions here. A protected area is defined as any area of land or sea managed for the persistence of biodiversity. A reserve system describes a system of protected areas. And the first interest in protected areas was pushed by wealthy socialites who were really interested in having scenic areas to go for recreation. And they really drove the first push for ecologically sound protected areas by hunters and those who just enjoy nature. We can take a look at the comparison between the percent of each major biome and its protected status. Here we have the different biome in the middle, and we can see on the left the percent converted from 0 all the way to 60, or the percent protected from 0% to 40. And we see by and large that flooded grasslands and savannas have the most area that is protected, and our tropical and subtropical seasonal forests are the most converted. Some of the first protected areas in the United States here, we established Yosemite National Park in 1864. There's a beautiful image of Yosemite right here. And then shortly after, in 1872, we established Yellowstone National Park. And here's a beautiful image of Grand Prismatic Hot Spring. Not sure if you know, but Yellowstone is sitting on a massive caldera of a volcano, and it is technically a super volcano, and it is overdue for an eruption. But all of that scary stuff set aside, that's why Yellowstone National Park has these beautiful geothermal features. It's because it is a very tectonically or volcanically active area. In 1879, we got the Royal National Park in Sydney, Australia. And then finally in 1892, in South Africa, they established Kruger National Park. So these are some of the first protected areas on the globe. We can take a look through time and see how the growth of protected areas has changed. And here's a graph with a year going from 1907 through 2007, and the total area protected on the left and the number of sites on the right. This graph even gives you more information because it's broken down by type, with terrestrial area outlined in green, marine area outlined in blue. And you see that we really saw this dramatic increase in the number of protected areas really in the 1970s, 1980s, and it's beginning to plateau here as this graph nears 2007, especially for the terrestrial sites. It began to have this linear curve for marine sites really early on. So marine protected areas have always had this low status for protection on this linear trajectory, whereas for terrestrial sites, it really had this sort of exponential growth in the number of sites and protected area. This is just another way to depict that with a few more years stuck to the end. So that last graph went to 2007. Here we have data through 2011. There are different types, as you can imagine, of protected areas, and these are the different types summarized. There's different tiers here, going all the way from strict nature preserve, wilderness area, national park, natural monument, habitat or species management area, protected landscape or seascape, and then finally manage resource protected area. Here are the definitions for those different categories. Please read these and their explanations. In addition to that, there are also some additional classifications, including biosphere reserves, Ramsar wetlands, and World Heritage Sites. For example, Yellowstone and a specific crater in Central Africa, these are both biosphere preserves and World Heritage Sites. Currently, there are 411 biosphere reserves in 94 countries across the globe, and the objective in these biosphere reserves is pretty variable, and it stretches everything from research to monitoring to training and then demonstration and obviously conservation. Here is a schematic of the design of a biosphere preserve where you have the reserve core in the central. You have then a buffer zone that surrounds the reserve core, and then finally into the transition area that is the boundary around the entire biosphere reserve. So in between the transition area and the reserve core, you have that buffer zone. A specific example of this biosphere reserve is again Yellowstone National Park and the quote greater Yellowstone ecosystem that you can visit mainly in Wyoming, but also bleeds into Montana. And so here we have the national park outlined in this sort of darker gray here. We have the buffer protected areas in the lighter gray, and then finally the major lakes in between here in black. So focusing in on the effectiveness of management practices in these biosphere preserves and natural parks, the threats to protected areas must be minimalized or eliminated completely in order to maximize the effectiveness of these management practices. And so there are a number of ways to measure the effectiveness, including design, management, and then just seeing if objectives that were clearly outlined from the outset were met. And many protected areas lack resources, and because of that, they are inadequately managed. Despite this, protected areas have been shown to be effective in a number of ways. This includes species abundance and diversity just being higher after those management practices are instituted. Also, preventing extinction of key organisms. In addition, native vegetation that's being maintained in the area and protected from extinction or overgrazing. And then finally, ecological processes that are being maintained, and there's a balance and a harmony in that area that's being managed that is maintained through management practices. And especially in aquatic systems, there's compelling irrefutable evidence that protecting areas from fishing rapidly increases abundance, average body size, and biomass of exploited species. So all of this in terms of management effectiveness goes for those marine ecosystems as well as those terrestrial ecosystems. So planning a reserve system, the purpose of a reserve, as you can imagine, is to protect and sustain a representative sample of the full range of biodiversity and processes of a region. Thus, a reserve system is often created for one or all of the following purposes outlined here. So a reserve system wants to protect usually particular species that are identified to be threatened or are flagship species. In addition to focusing on specific species that may be threatened, just preserving overall biodiversity is extremely important in the reserve system. And by preserving that biodiversity, you're also preserving the functioning overall of that entire ecosystem and the associated services that each species brings to that community. Species survival can depend on preservation size and shape. So Ideally, a reserve should be large enough to support endangered species and simultaneously keep the ecosystem intact. But a lot of smaller reserves can be connected through corridors, which allow movement between reserves. So as you can see here, there's a reserve here in dark green, another one, and another one. There are these corridors that allow transmission of species between the different reserve areas. So many natural parks and preserves actually are increasingly isolated, and there are remnant fragments of ecosystems that once extended over large areas. As park ecosystems are shrinking, however, it is really, really important that we take steps to increase and maintain biodiversity. This really leans upon principles of landscape design and landscape structure. These become important pillars in the management and restoring of these shrinking islands of habitats. And it's actually been an ongoing dispute in the conservation circles and conservation biologists who have disputed whether it's better to have a single large reserve or several small reserves. So this is still under debate with conservation biologists, but overall, ideally, a reserve should be large enough to support viable populations of those endangered species that you're seeking to protect. It should also keep ecosystems intact, and finally, isolate critical core areas from damaging external forces. And then finally, marine ecosystems, they actually need greater protection than our terrestrial ecosystems. Only about 5% of nearshore marine biomes are protected. So that goes back to those charts that we saw, the growth of protected areas through time. Really, the marine areas are not seeing nearly as much protection extended to them as the terrestrial ones. And reducing fishing in marine reserves can quickly replenish fish stocks in surrounding areas. So that is one behavior and management practice that can be instituted to preserve ecosystem functioning and species diversity. And just to sum all of this up and really drive home the point that marine ecosystems need greater protection, they often take a lot longer to bounce back after management practices are instituted. And coral reefs can take a century or more to recover from damage, and therefore they require greater protection. And finally, I'm going to ask you to please read page 145, Wildlife or Oil, in your textbook. And there's also a link to an NPR story that provides an update on the status of drilling in the Arctic Wildlife National Preserve.